Hello, we are on page 227, lesson 12, session 1. We are working on, if it goes to it, adding fractions is what we're working on today. So we've worked on adding decimals, subtracting decimals. Now we're going to work on adding fractions. This is something that you touched on a little bit in 4th grade. We worked a little bit on it, not a whole lot, but we're going to definitely build off what we did last year, and hopefully it'll kind of help you with us working on it this year. So, we can use fraction tiles to make 5 fractions equivalent to 1/2. So, do you remember finding equivalent fractions last year? Does anybody remember how to find equivalent fractions? Cole, do you remember? What do we do?
You have the 1 over 2, you have a half, and then you just find another fraction that's just like half.
Another fraction that equals 1/2, right? How can we do that? Nolan?
You multiply the divisors and then you do the left divisor times the right hand divider.
Nope, you're thinking too far. You're thinking harder than you have to. We just want to make this 1/2. How can we do it? Or make another fraction that's the same? Gabe? Well, how do we get it? What do we do? Michael?
You have for 6, you have to times the 1 by 3 and the 2 by 3.
Yeah, you just multiply the numerator and denominator by the same number. And it's an equivalent fraction, right? If I times 2 by... What the heck? If I times 2 by 3 times 1 by 3, I get 3 over 6, right? I guess I could put it on things and whatever. Now, what's another equivalent fraction to 1/2? What else could I multiply it by? Cole? I times the top number and bottom number by the same number. Times 1 by 3 times 2 by 3, I got 3/6. I can times each one by 2, right? So I can times 1 by 2 times the 2 by 2. 2 over 4. Is that equivalent to 1/2? What's another one, Gabe? Times each one by 12? Times 2 by 12, I get 24. Times 1 by 12, I get 12. 12 24. Is that equivalent to 1/2? Are they all the same number, all the same value? Think about it this way. I have a pizza. I cut it in half. I have 1 piece and 2 pieces, right? Jacob eats the 1 piece. So he ate half the pizza, right? He ate 1 out of 2. Now, imagine I cut a pizza into 6 pieces. Or into 6 pieces. And Caden eats 3 of them. Did Caden and Jacob eat the same amount of pizza?
Yeah.
They each ate half the pizza, right? And then I take another pizza and I cut it into 4 pieces. And Chris eats 2 of them. Did Chris eat the same amount of pizza as Caden and Jacob? Yeah, they all ate the same amount, right? And then I cut another pizza into 12 pieces, or into 24 pieces. And Nolan eats 12 of them. Did he eat the same amount of pizza as the other guys?
Yeah.
Yeah, it's all the same amount of pizza, but where they're different fractions, right? They're a different amount of cuts. What's another fraction that's equivalent to 1/2 that we can find out, Chris?
100.
What do you mean? What am I doing with
100
100?
over 200.
100 over 200. What did you times the denominator and the numerator by?
100.
Times 2 times 100, I get 200, right? Times 1 by 100, I get 100. Last one, what else could there be? Caden? 18 pieces cut overall. And what do I times 2 by the 18? Oh, okay, you're saying times it by 18. I times 18. 1 times 18 is 18. What's 2 times 18? Not 32. 36.
Could you add one more?
No, you guys see how we're doing it now?
Yeah.
Just times numerator and denominator by the same number. Now they're equal, right? Does 1836 equal 1/2?
Yes.
Does 100 over 200 equal 1/2? 3/6 equal 1/2? 2/4 equal 1/2? 12/24 equal 1/2. They're all the same value, right? As long as your whole is the same, those are all the same, right? Remember talking about that last year? We talked a little bit about it.
Can I say the last one that I have?
No. Save it for some other time. So, we're going to work a little bit on that. So, Emiliano needs half a stick of butter to make cornbread. He also needs 1/4 a stick of butter to make apple muffins. What fraction of a stick of butter does he need in all? I'm going to give you 4 minutes to try solving that. See if you can remember how we do it. I'm not ready to put your hand down. I said 4 minutes.
Perfect. You have no clue what that is? It's easy. Is it less?
Are you? Yeah, you might be seeing
Mr. Bentley, is this right?
No.
Well, my mom, when I baked for my mom, she asked me to cut 2
Oh, we'll talk. Oh, yeah, just different. We're talking fractions. We're not talking
I don't know.
sure.
But still, is the number right?
No.
What?
No. No. We're gonna go over in a minute. You guys have 2 minutes left. No. Is it? No. No. We'll talk about it. No.
Oh, is it that?
No. It's not gonna be a whole number answer.
It ain't?
No.
What's a whole number again?
Like 2 or 4. It's a fraction answer. All right, let's look at it. So there's a couple ways you could do this. We need to find, we're adding, right?
Yeah.
What do you always have to have when you add fractions? What's the first thing you got to find if the denominators are different? What do you got to do, Chris? You got to make the denominators the same. What's the denominator again? What? Well, yeah, let's go over that first. What goes on top?
Numerator.
Numerator's on top. The n is always on top, right, Nolan?
Yeah.
Nolan is always on top.
No one's dad is always on the bottom.
What's on the bottom?
Dad.
Nolan's dad is always on the bottom. So denominator's on the bottom.
Man, I wish my name started with N.
Nolan's on top, his dad is on the bottom. Numerator's on top, denominator's on the bottom.
Ooh, how about
So, I'm pretty sure I spelled denominator wrong, but we don't care about that right now. That's fine. So, the denominator always has to be the same when you're adding fractions. I'm going to say this right now. when you add and subtract fractions, the bottom number for both fractions have to be the same, right?
Right.
That makes sense?
Right.
They have to be the same. So if I have 1/4 plus 1/2, what two numbers have to be the same?
The denominators.
Yes, but what two numbers up there?
4 and 2.
The 4 and 2. I gotta make this number the same as this number. They have to be the same. So how can I change both those numbers and make them the same? Nolan?
Multiply.
Multiplying what?
4 times 2.
Multiplying times each other. Times this one by 2. Times this one by 4. 2, 4 times 2 is what?
8.
8. 2 times 4 is.
8.
Are they the same now?
Yeah. No.
Well, now, one difference. What I do to the bottom, I must do to the what?
Top.
What I do to the bottom, I must do to the.
Top.
What I do to the bottom, I must do to the.
Top.
What I do to the bottom, I must do to the.
Top.
Remember that. If I do something to the bottom,
I'm going to the top.
you have to do it to the top.
Yeah. Top.
Yes. When you do something. When you do something to the bottom number, when you do something to the denominator, listen, please, this is important because this is where you guys always screw up at. When you multiply the denominator by a number, you must multiply the numerator by the what?
Number.
The same number. What did I multiply this 4 by?
2.
What do I times the 1 by?
2.
1 times 2 is what?
2.
That 1/4 is now what?
2 8.
2 eighths. What do I got to do this one though?
Multiply the left-hand denominator times.
Oh, no, just times by the same denominator, right? What did I do to the 2?
You just put a 4 there.
Multiplied it by what?
4.
Multiplied by 4. I times 2 times 4. And what I do to the bottom, I must do to the
Top.
2 times 4, so I do 1 times 4, right? What's 1 times 4, Hayden?
1 times 4 would be
4. Do they have the same denominators now? Are they the same fractions?
Yep.
They're equivalent, right?
You.
Now you just add. Now, pay attention, Miller. I add 2 plus 4 is what?
6.
Do I add the denominators?
No.
No, you leave the denominators alone. You just add numerators. What's my answer?
6 8.
6 eighths. Now, then I'll accept that answer for right now. But when you get older, that's not the right answer. Because is that fraction in lowest terms?
No.
Can I take something out of the numerator and denominator?
Yeah.
What can I take out of each one? What's a factor of 6 and a factor of 8 that they both share?
2.
2. What's 6 divided by 2?
3.
What's 8 divided by 2?
4. You wrote 2.
Well,
8.
yeah, 6 divided by 2 is 3. 8 divided by 2 is 4. I'm right.
You can't
It's
even
3
read all
fourths.
now.
3 for a stick of butter. Does that make sense how we did that? We're going to keep working on it. This is how you add fractions.
I thought it was tablespoons.
Tablespoons are just the little things they have on the side of the stick of butter that you cut.
Yeah,
We're not doing that here.
My mom told me every time I bake with her, she's like, "Can you cut me 5?"
Yeah, but because if you go off a cookbook, that's how they have it listed now. They don't do the quarters and sticks.
Cut me.
But
one
no,
tablespoon
Cole,
of
Cole,
butter.
Cole. We're talking about fractions now, okay? We're not talking tablespoons. So, shh. How can you find how much butter Emiliano needs? How do you do it? Well, tell me what you just did. Write down there what you just did. What did we do first? What do we look? What do we have to find first?
The same.
The same what? We found a common denominator. We found a common denominator. That's our first step, right? What did we do then? Huh? What did we do then? We found the common denominator. Cole?
When we find the common numerator?
Not common numerator. We made sure that they were equivalent fractions, right? We found equivalent fractions. And what did we do lastly? Added what?
The fractions.
Not the fractions. We added the what, Nolan?
Numerator.
We added the numerators. It's not hard. It's a couple steps in there, but it's not devastatingly hard, right? You guys will get some practice, huh?
I got that.
You were making mixed numbers, right? Or improper fractions.
I thought I was doing
Okay.
Mr. Pratt.
Oh, that's dividing fractions.
Mr. Pratt.
We'll get there. That you use it to divide fractions. That do this times the cross multiply. Leave it, change it, flip it. It's cross multiply thing.
Mr. Pratt.
We'll just hold on to it. Don't worry about it. Just do what we just did, right?
Mr. Pratt.
What you're talking about when you do that, you multiply by the opposite side.
Yeah, I meant like I was going like that.
Yes, that's a calculus thing. You do that. That is such a thing, but you don't do it now, right?
Hey, I got a
Oh, don't do that now, all right?
Can I say something?
No. All right. So, what's up, man?
I don't get it.
We're gonna work on it. We'll work on it some more. We just did one problem. Just pump the brakes, okay? All right. Looking ahead. Before adding fractions, the fractions must have the same size parts of a whole. Can I add two fractions if the wholes are different? Can I add if I said I want to know what fraction of a pizza Gabe ate compared to the fraction that Jacob ate, and Gabe ate a large pizza and Jacob ate a medium pizza? Could you do that? Can I compare them? Can I add them together?
No.
No, why not?
Two different pizzas.
Two different sizes of pizza. I can't, when I want to figure out, if I say I ate a quarter of a medium pizza, Mr. Richmond ate a quarter of a large pizza, can we add those two pizzas together to find out how much we ate together? We can't, can we? Because I ate a what? Medium, he ate a large. They're two different sizes. Can we add a number fractions that they have two different holes? No. If I was to say, Gabe drank half of his mug, and Caden drank 3/4 of his mug. Hayden. If Hayden drank 3/4 of his mug, shh. Can we add these together and figure out what fraction they drank?
No.
Why not?
They're different sizes.
They're different sizes. You can't do it when they're two different size mugs. Yes.
You did
Sorry.
that earlier.
Wait, did I say Hayden earlier?
You saw
Um,
You did it again. You can't do it. You can't do it.
So, before adding fractions, you have to make sure they have the same size whole. If the wholes are different sizes, we cannot add them. You can use what you know about multiples and equivalent fractions to find the common denominator for fractions that have unlike denominators. We did this last year. We worked on finding common denominators and equivalent fractions last year. Boys, use the fraction 1/2 and 1/3. Write the next 4 multiples of each denominator. So, we have 1/2 and 1/3. What are my two denominators? What's the denominator for 1/2? 2. What's the denominator for 1/3?
3.
Alright, let's list the next 4 multiples of each. Well, what is a multiple? Going back to 4th grade, what is a multiple? Michael?
Wait, of 2?
Well, no, what is a multiple? What does a multiple mean? What does the word multiple mean? Gabe? It's what if you were to multiply it, it would equal it. So what's the first multiple of 2? 4. What's the next multiple of 2?
6.
What's the next multiple of 2?
8.
What's the next multiple of 2? Alright, you see how that works? If I was to multiply 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Those are all multiples. What if I was to multiply by 2, what is all the possible answers could be? Those are all the multiples of 2, Lucas. Does that make sense? Alright, because you weren't paying attention at all. So what's the next multiple of 3, Lucas?
6.
6. Because 3 times 2 is 6. What's after 6? Alexis? 9. What's the next multiple of 3? Jacob?
12.
12. What's the next multiple of 3? Caden? 15. We're kind of counting by 3s and 2s, aren't we? So we found some common multiples of 3, right? I have a question. Does 2 and 3 share a common multiple? Do they have a multiple that they both have in common? Lucas?
Yeah.
Which one?
6.
6. They both share 6, right? What do I multiply 2 by to get 6? Nolan?
3.
3. So I times 2 times 3. What do I multiply 3 by to get 6? 2. So what is 6 going to be our common denominator? Yeah, because it's a multiple of both, right? So let's go down to the pictures now. What did I multiply 2 by to get 3 or 6?
3.
2 times 3 equals 6. What I do to the bottom, I must do to the...
Top.
So what do I times that 1 by?
3.
3. What is 1 times 3?
3.
So I put 3 in this box right here. So 1/2 is equal to what?
3, 6.
3, 6. Now, just to do the picture justice, shade in 3 of those 6s in that circle. 1, 2, 3. Is there the same amount shaded in each circle?
Yeah.
Yeah. Are they equivalent fractions?
Yep.
Yes. So, what did I multiply 3 by to get 6? What did I multiply 3 by to get 6, Alexis? 2. So what am I going to multiply that 1 by, Alexis? 2. What is 1 times 2? So how much of that one am I going to shade in?
2.
Now, if I was to add 3 6 and 2 6, now I just got to count them, right? 1, 2, 3, 5. So 1/2 plus 1/3 is equal to what? 1, 2, 3, 4, 5 out of a possible 6. So use equivalent fraction to add. 1/2 plus 1/3 is equal to 3 6 plus 2 6. 3 plus 2 is equal to 5. Does that make sense now a little bit more how we're doing this? Clear anything up? Clear as mud? Alright, we're going to keep working on this. This is a rather long unit. We'll keep going on it, alright?
Now it's reflect.
Reflect. What equivalent fractions could you write to add 1/2 and 2/3? What other fractions could you possibly use? that are equivalent to 1/2 and 2/3. What's another common multiple they have? Does 3 go into 4? No. Amelia? Does 3 go into 2? Michael?
12.
12. Does 3 go into 12?
Yes.
Does 2 go into 12?
Yes.
What do I multiply 2 by to get 12? Raise your hand.
2.
2 times 2 equals 12?
No, 6.
2 times what equals 12, Amelia? 6 equals 12. What do I times 2 by 6, what do I multiply the 1 by?
6.
1 6 times 6 is 6. Now I have 2/3, right? 2/3. What do I times 3 by to get 12? Cole?
4.
3 times 4 equals 12. What I do to the bottom, I must do to the...
Top.
2 times 4 equals 8. Is 6/12 and 8/12 the same denominator? Are they equivalent to the original fractions?
Yep.
Can I add them?
Yep.
What's 6 plus 8?
14.
14 12s, right? Now, there's a whole other issue there. Is that proper?
No.
No, because why? Amelia?
14 is higher than 12.
The numerator is bigger than the denominator. So what do I got to do?
2 by 2.
Do you know what we got to do? Here. We know that 12 over 12 equals 1, right? So what if I take one whole out? What am I taking away from 14? 12. And that's left with 2 12s. And I really could go a step further. Is that in lowest terms? What can I take away from 12 and take away from the other one? I can take a 2 away from each one, right? 2 divided by 2 equals 1. 12 divided by 2.
6.
My answer is 1
6.
and 1/6. Now you're going to say, Mr. Patrick, this is ridiculous. When would I ever use this? No, you would. I'm telling you right now. I'm going to be completely honest. My dad didn't even graduate high school. He uses this every day. His whole life. Your grandpa and all your family uses this every day. Yours family does. Your family does. I'm sure everybody else's family does too.
My dad.
When would they use this? I can tell you, when would they use this, Caden? On wrenches. Wrenches go off of fraction sizes, right? Your 3/4 inch wrench. Your 12, your
12 inch.
no, not your 12 inches. Your like 5/8 wrench. Your 9/16. Those are all fractions. Now, you're gonna, Mr. Patrick, those are easy though, right? Well, no, they're not. Because here's the deal. Say you go to work on your, put your hand down, I'll get you a second. And you go to work on something, and you grab a 1/2 inch wrench, and you put it on, and oh crap, it's too big. I gotta find out what the size wrench next to smallest. So I know that 1/2 it's too big, right? So then I gotta say, okay, what's the next size smaller than 1/2? I know wrenches typically go by 16ths. So I gotta find, okay, 2 times what equals 16? 8, right? So I times the 2 by 8 to get 16. What do I gotta do to the 1/2? The 1 on the 1/2 times it by 8. So and then I know 1/2 wrench is equivalent to a 8/16 wrench. And then I gotta say, okay, then what is one size smaller than 8/16 wrench? 7/16 wrench. So that's how I know what size I gotta pick next. You'll eventually memorize it. But I'm telling you, even if you're not planning on going to college or I'm not even finishing high school, that matter, you need to know how to do these fractions. It's a must. You'll use it in mechanics, working on cars, working on trucks, taking things apart, putting things together. You'll use it as carpentry. I worked with my father-in-law a lot. He's a builder. We're always trying to add and subtract, multiply and divide fractions of measurements, trying to figure out how long of a board we need next. And we sit there and, I mean, literally, we'll pull out little pieces of scrap paper that we have in our wallets to do it. Or we're doing it in our heads. So you will use these. I will promise you, everybody will use this. This is not something that you're not going to use. If there's one thing that you learn in math this year, this is probably the most important thing. Adding, subtracting, multiplying, dividing fractions. Yes, Cole.
My dad uses it every day to work on his skid steer.
I'm sure he does.
The skid steer's always broken.
So, okay. That is it for today. You guys can go ahead and go illuminate.
Illuminate.
Or not illuminate, it's called illuminate for me. It's illumination math, right?
No.
Imagine math. Sorry, I don't know. So as soon as this thing works,
Break the skid steer.
hang on, I gotta get this.